Hey guys, Buildzoid here, and today we're just going to be taking a look at a new memory kit that I recently picked up. So it's this right here, the Patriot Viper Steel 4400 megahertz DDR4. It's a 16 gig kit, 2x8, so single rank memory sticks. And yeah, there's, not really much else to it. It was really, really cheap on eBay. It was going for like, I think 104 quid, even with shipping. So yeah, that's the main reason I picked it up for 4400 megahertz, because this is B-die. Like, this is 4400 megahertz, 191919 primary timings, so it has to be B-die because nothing else does TRCD that low at that kind of frequency. It ships at 1.45 volts. Now, a lot of people might be like, 4400 CL19, that sounds rather loose, except it's not, because most people don't know how timings work. So basically, if we take 4400 and then we divide it by 19, and somebody's going to go, but Buildzoid, that's not how you calculate latency. That's not the bloody point. I don't care about calculating latency. But anyway, so take 4400, divide by 19, multiply that by 14. So now we're going to compare it to, like, well, what kind of frequency would this memory kit have to run at if it was at cast latency 14? And oh, it's 3242 megahertz. So basically, this is a tighter memory kit than a 3200 CL14. Admittedly, it also comes at a higher stock voltage. I think it's 1.4 or 1. I think it's 1.45 volts for this one. I really don't care about the stock settings on this kit, to be completely honest. I basically went, it's cheap. It's the highest frequency bin that Patriot does, because basically, I've been complaining that my B-die memory collection kind of sucks for a while now. And so, I wanted to try I wanted to roll the dice on the Silicon Lottery again, and decided to pick this up. And the logic behind going for this was, well, it's cheap. It's the highest bin of B-die that Patriot makes. So it's like, Patriot is, they're going to buy a bunch of Samsung B-die from Samsung, or from some kind of, actually, they'll probably buy it from a broker, because you don't normally buy direct, like, it depends how big the memory manufacturer is, if they actually buy directly from the RAM manufacturer or through a third party. They, like, basically, they're going to have a pile of B-die, and they're going to bin all of it. Where's all the best B-die going to go? Right? That's the question. Where's the best B-die going to go? It's going to go into these, because these are 4400 megahertz. It's the highest spec kit that they make. So I was like, okay, well, since this is the highest spec kit that they make, there's a pretty good chance that these might not suck, and it's really cheap, so why the hell not? And I picked up a kit, and here's the actual memory sticks. Now, this is extremely cheap B-die, so you can't expect, if you get like G-Skill Tridents or something, you get really chunky aluminum heatsinks, which are really just kind of a waste of money, because ultimately that heatsink doesn't actually make the memory chips any better, right? Like, that's the thing. So the heat spreader on these is, like, it's flimsy. And this right here is just a piece of plastic. I do think it looks okay as far as heat spreaders go. Like, I don't think it's the most ugly one ever. There are some that are, in my opinion, absolutely horrendous. Primarily the Trident Z Royals. I think those are absolutely some of the worst looking memory sticks I've ever seen. Sure. So these, in my opinion, aren't too bad, mostly because they're black, like they're gray. So, that's the main thing I care about. Anyway, so the memory layout on these is, it's an A2 layout, so you have 4 memory chips over here, 4 memory chips over there. And yeah, so, these should be good for high frequency, and I can actually say, yeah, I've had them all the way up to 4800 megahertz already. But the main thing I really wanted to do with these was try for high frequency at CL12. And this is currently the best kit of B-die I own. It's honestly kind of ridiculous how much better these are than everything else I have. So yeah, and I was testing them on the Maximus 11 gene. It looks like Asus finally fixed the, well, I actually don't know if it, like, the thing is, the Maximus 11 gene, I've not used that board that much, because when I first got it, I realized that Asus evidently just completely forgot that, A2 memory layout memory sticks exist, and so I couldn't overclock my memory at all on that board. I think, like, the best settings I could run was like 4400 CL16. Anything tighter than that doesn't post. Anything higher frequency than that doesn't post either. But on the latest BIOS, the actual, these actually clock really well on the latest BIOS. So I think they fixed that. I might have to go through my memory collection and retest all the memory sticks now. And I'm actually, like, they maybe fixed that a couple BIOS revisions ago. Like, I've really not used that board for ages and ages and ages. Anyway, I want to show you the kind of settings that I've managed to get these to do. So we're going to be switching over to here. And yeah, I'll throw them in the gene, and I'll show you where I've managed to push them to. So I did clear the BIOS on the board. So we're not going to go through like a full overclocking process here because, well, doing the settings I wanted to do took forever to actually get, like I think I spent basically an entire day with these memory sticks, just like pushing them around. Because the other thing is I'm not that used to using the Maximus 11 gene. I do have the board in LN2 mode right now. The reason why I have it in LN2 mode is basically without LN2 mode, the DRAM voltage on this board is normally limited to only 2 volts. But if you're in LN2 mode, it's limited to, well, insane levels. So get the idea. Anyway, so we're just going to load up, I'm just going to load up the XMP and show you what these default to. Bam. So yeah, so they default to 1.45 volts. Primary timings of 19, 19, 39. So this is actually like, this is not the, like, this is relatively tight for what it is. So anyway, now we're going to load up my profile. And we're going to go for profile 1. And so the thing is, if you're on a Maximus 11 gene, or I think any Maximus board these days, with LN2 mode, there's a few things you have to do if you're going to be running LN2 mode at ambient. So you need to go into Tweaker's Paradise, and you need to set your PLL bandwidth to like level 1. And I think it's level 1, because here's the really stupid thing. So this PLL bandwidth setting is not actually a PLL, and like this is by Intel spec, this should be called VCC PLL underscore OC. This is a voltage that's used for cold bug removal, which is why you need to manually set it if you're in LN2 mode at ambient, because if you enable LN2 mode and you don't change this, the motherboard will automatically set it to like cold bug removal settings. So basically, it'll set it really, really high, which is fine. It won't harm your CPU as far as I know, but it'll completely break your temperature sensors. So your temperature readings are going to be way off. As in really, really high. Like you're going to be doing, like you're going to be idling at like 70 degrees if that is maxed out. So anyway, that's the PLL bandwidth. Like, so you need to set that to like a reasonable level, like level 1. I'm actually not sure. Like the issue is I don't know, like Asus doesn't tell you what the standard setting for PLL bandwidth is, because it's supposed to be 1.2 volts by spec, but those aren't voltages. Those are Asus made up level settings, which is one of those things about Asus BIOS that, like, the other thing that I hate about Asus BIOS, I'll just show you right now, is seriously, like Asus and their BIOS naming schemes, like that's an on-die termination setting. And it's measured in clock cycles because, you know, resistances are measured in clock cycles. Asus BIOS, man. Like, and the reason why Asus does this is basically to like hide the way their BIOS works from other motherboard vendors. But I still think it's just absolutely freaking stupid. Like, it's just like, it basically means that if you're used to using Asus motherboards and then you go to using another motherboard, you're going to be super screwed because Asus doesn't use normal naming conventions, which is just like, are you kidding me? Like, if it was some special set, like, especially for PLL bandwidth, if it was a setting that was, like, not in the Intel data sheets, then I would be like, okay, sure, you can name it whatever you want because there's no official name for what it's supposed to be. But this is VCC PLL underscore OC. Like, just call it what it freaking is, guys. Anyway, the other thing you need to do is set your PLL termination voltage to, well, 1.05 volts, because otherwise it'll default that really high as well. Yeah. Now with these memory sticks, what I found is for best stability, I do need to run the VTT DDR. Like this is actually kind of interesting because a lot of my other B-die memory kits that are all like A2 PCB layouts as well, most of those need a DRAM VTT voltage of like 0.937 or 0.95. This kit needs very specifically just under 1 volt. Actually, it'll work okay-ish at 1 volt, but if you go above 1 volt, it doesn't like that. If you go much below this, it doesn't like that. So, yeah, this is a... I mean, it's just kind of strange to me that it's about 50 millivolts more than all of my other memory, so kind of interesting in that way. Though there are some memory kits which really don't care, that you can just whack 2.1 volts into and you don't need to touch the VTT DDR. My RGB dominators are a perfect example of that, where it's just like, hey, you just raise the voltage and they'll take it. You don't need to mess with VTT DDR at all. Anyway, here's all the different timings that I manually set. You have to put the board, I'm not sure if it's specific to all A2 memory, but with this memory kit at least, you have to have it in mode 2 for the Maximus tweak. I really wish I knew what that did, but again, Asus BIOS, they don't really care about telling you what everything does. So 1212, for whatever reason, I think it's a CPU thing. Like, I think the CPU literally just can't do TRCD11, because this is a constant problem for me with this CPU everywhere. It's just like, could you please do TRCD11 at high frequency? No. Okay, so we're at 1212. The kit might do 1211, but I need to check some other chips. TRFC I can do 200, which is pretty cool, because we are actually at 4174 megahertz. Like, it's going. Like, it's going pretty damn fast. This is actually like 174 megahertz, but better than basically every other DDR4 kit I own. So I'm super, super happy with this memory. Now, again, you know, it's Silicon Lottery, so you could buy 10 of these and not get a single kit that is this good, but evidently there's potential for some of them to be really damn good. So, yeah, TRFC 200, 65,000 refresh interval. This is just sort of normal B-die things for the timings. Then we have 6 for RTP, 16 TFAW, 6119, right? So this is pretty normal. I tried TCWL8, doesn't work, unfortunately. At least not at this kind of frequency. Maybe at 3800 it might do it, but I don't really care. Then I also have, where is it? These two are set. Yeah, so then 2116. Also, because the Gene's memory training is dumb as, like, well... The thing is basically, if you can, like, the memory training on a lot of motherboards isn't super consistent. So on the Gene, I do actually have the RTLs locked down to optimal settings, so 495066, because otherwise the board will sometimes train to like 4951, or I think I had one time where it trained 5951, and it was like, that's wrong. Like, it literally is just setting the settings wrong. So I think at 4,000 megahertz, it automatically trains into the correct values, but at higher frequencies, it starts doing weird things. So I have to lock these down, because like, if your RTLs mistrain, you get basically all kinds of issues, like your performance sucks for no reason, your stability sucks for no reason, that kind of thing. So yeah, at the same time, the RTLs, you can't just like I think there's a way to calculate what they're supposed to be. But, actually, no, because there's like, because the settings are somewhat board specific. So, actually, not somewhat, they're definitely board specific. Like certain motherboards, like, because this, I'm not going to get into it. Basically, these timings are magic, and 495066 with this configuration happens to work. Okay, on other motherboards, 495066 is not going to work at all. But generally, like 2DIMM extreme overclocking focus boards will run 495066, assuming that, like, for this set of timings, that's just what should work. It's just not all motherboards can necessarily do it. Not all memory kits can necessarily do it either. Oh, and the last setting that you need to set is this right here. That has to be enabled. Normally, that's disabled. If you don't have that enabled, basically, like, there's a breakpoint where you have to enable the mode 2 and the trace centering, which I think is like CL14. Like, I think it's like CL15. If you go down, like, 4000 CL16 is totally possible with everything just on the defaults from the motherboard, which is like mode 1, trace centering disabled, all that. And Once you try to go below that, if you keep everything mode 1, trace centering disabled, it doesn't work anymore. So, like, it's not going to train. So you need to enable trace centering in mode 2 if you want to push the timings even lower than that. So, yeah. Anyway, we're going to boot up with this. It is set to 5.5 gigahertz right now because basically when I realized that, whoa, this memory is great, I also decided, hey, I'm going to see if I can do a sub 6 minute SuperPi 32 million. Admittedly, I'm using Windows 10, so it's not efficient, but just, you know, ambient sub 6 minutes is pretty cool, I think, anyway. So... yeah, I also have the CPU like down cored because SuperPi is a single threaded benchmark, so you don't want hyper-threading and you don't want all of your cores enabled. So we're going to save and reset. Might take the board a few tries to actually post. All I have for cooling on the memory is just a fan. And actually even, well, no, the fan is kind of useful. So this is normal. The board needs to boot loop a few times when you're pushing the memory settings this aggressive. Also, I have the memo K switch disabled because the memo K switch is dumb. It just makes things worse. It doesn't make things better. I don't know what it's supposed to do, but in my experience, it just makes things worse. So, yeah, okay, so 05, that's fine. We're just going to retry through that. So this is the reason why Asus motherboards have retry buttons. It's because they don't always post immediately. So, and the thing is actually, no, that was a 50, not a 05, but wait, 32, 35, and there we go. So yeah, sometimes it'll get stuck on BF, but basically there's postcodes like, there's a couple postcodes which if you get are basically your memory settings are wrong and you need to go fix them. And it's like B1, I think is B1 is either too tight or too little voltage. Then there's like 33, which is just your timings are wrong, if I remember correctly. Like, I didn't really bother to take notes while I was doing this. So yeah, I spent an entire day, but I didn't write down a single thing. And yeah, I'm just going to pull up ASRock timing utility to show you all the timings right now. So, what is this? Yeah, so 12, 12, 12, 28, 1T, right? All of that. And then all of this right here. And, like, I'm not actually going to run any... Well, we can run IDA. We can run IDA. I can show you some seriously low latency here. So this should do just over 30 nanoseconds. Unfortunately, at 4180, this memory kit doesn't train anymore. So this is very much like the absolute limit of what I can do right now. Yeah. So, okay, we're getting just over 30 nanoseconds. Which is not actually the best result I've gotten. I have a 30.1 screenshot, which is right here. Oops. So yeah, there, 30.1, and that's at also 4173. That's literally at this memory profile. So. Yeah, and then there's the SuperPi, which, there, it completed it at 5.55 gigahertz, and kind of insane voltage, but yeah, just under 6 minutes. Not, like, this isn't efficient. You shouldn't run SuperPi on Windows 10, but SuperPi is, like, one of the most memory-intensive benchmarks there is. Unfortunately, so it's, like, a good way to check if, like, a memory kit is good, which is why I was running it. It's just like, hey, can the memory kit do this? And then, yeah, it can. So this is right now the best memory in my collection, which, yeah, I'm pretty excited about. And it's an A2 layout. Like, that's kind of the neat thing is just, because normally, like, it's kind of funny is just, like, most people would tell you that you need an A0, but nah, A2 just needs the motherboards to support it properly. And then you need to get lucky, because I have a whole bunch of other A2 memory that's not going to get anywhere near what this kit does. So... yeah, like the well, actually, I've not tested the Dominators on the Gene yet. They should do 4,000 though. Yeah. So I'm really I'm really happy with this kit. Like, I honestly wasn't expecting. Like, when I got it, I was just like, well, it's 100 quid. Worst case scenario, it wasn't really that big of a loss, and it can go into my daily system or something if it really sucks. But no, it's actually really solid memory. Other than, like, well, the heat spreaders are cheap, but still, if you're just, like, like, I don't care, right? Like, it's just like, I don't care if the heat spreaders are cheap or not. Like, this is by far the, and we're just going to switch cameras. Like, for the price, like, this is freaking great. Now, admittedly, entirely down to luck, right? So, you know, you might, as I said, you might buy 10 of these and not a single one is going to get anywhere near this, but, yeah, like, I'm kind of excited. Like, so mostly this video is about, like, those are the kinds of timings that, you want to run for, like, competitive benchmarking. Yeah, that's the kind of thing that's possible if you get a really, really good set of B die. Also, the voltage I'm running is so high that I would not run it long term. The other thing, oh, I forgot to mention this. If you're running B die above like 1.7 volts, you're gonna have to set Windows to not use all of the memory. So I'll just go back into the operating system. Hopefully it posts. But basically right now, the system is set up to have a restriction to use only use like 2.5 gigs of RAM. Because if I gave the operating system access to the entire 16 gigs of memory, it actually wouldn't be stable at all. We'd blue screen as soon as Windows tries to load, which also interestingly means that if you get like the startup repair thing while running high voltage on BDI, yeah, that'll blue screen as well. Because startup repair, for whatever reason, disables the memory restriction. So it tries to like load up all of the RAM and then it just gets really unstable. So I'm just going to pull up Task Manager here. You can clearly see, yeah, we're on 2.4 gigs of memory available because if I gave it 16 gigs, we wouldn't be able to post. Actually, I can prove that. So if we go into, this is msconfig. So if you don't, like, you know, if you want to know how to get to that, you do config, bam, you just do that. And then you go to advanced options and maximum memory. So I'll just disable that right now. I do believe like for 2.5 gigs, you need to punch in 4,500. There's also a terminal command that you can, wait, not terminal. There's a command line. Yeah, there's a command line command that you can use to restrict your memory. I just use this because this works well enough. Like this is actually like, there's some glitches with this, but it works well enough for me. So I don't care about doing it like the more proper way. It's just like I don't need that much accuracy. So yeah, and now we're not going to get into Windows. It's just going to blue screen immediately once it tries to restart. So that's kind of one of the weird quirks when you're really pushing BDI memory to the limit, is just like it gets super, like you can't even use all of it. Retry. Okay, retry again. There we go. Yeah, so as you can clearly see, it's just going to give you memory management errors, and you'll never make it into Windows. So then you need to basically like go into the BIOS, save a profile, clear the BIOS, go at stock settings into Windows, enable the memory limit, then you can go back up to your crazy memory settings, because otherwise like you're not making it into Windows. And it's doing BF again. So yeah, that's it for the video. That's all I really wanted to do, is just show off that I finally found a memory kit that can do more than 4,000 megahertz at CL12, which is like, the annoying thing is like it took me really long to find one. Like there's been, like I've actually seen people like, well, 4200 megahertz CL12 has been kind of like the diamond standard, right, for BDI out there, and it's just like, yeah, I finally now have one kit that can do 4174, which is yeah, still not that high, but by far, like, you know, like, considering that I only had to spend 100 quid for it, I'm really, really happy that, you know, this memory kit turned out so well. So, yeah, Patriot Viper Steel, 4400 megahertz. Also, it's worth noting that 4400 megahertz, this is such a high stock frequency that if you try to run this XMP on most motherboards, it won't work. So if you have like a motherboard with 4 memory slots, this will probably not work if you're on Z390. Also, well, nah, like, we don't need to get into that. I don't feel like that's not really that relevant. So, yeah. Anyway, that's it. That's it for the video. I didn't, like, the thing is, this kind of video is really awkward for me to do because it's just like, I don't know how to, like, what kind of format to do it in. Because it's just like, well, I'm not going to show you the process of getting there because it took me literally, oh, well, yeah, basically it took me a day to get to these settings because at some point, like, initially I was testing with Geekbench 3, and I think Geekbench 3 just, like, well, Dijkstra just wasn't passing. Dijkstra seems to be, for me, a bigger challenge than SuperPi, which is kind of ridiculous because Dijkstra is like a couple seconds and it really shouldn't be that difficult. But yeah, my 9900K hates it. So at 4133, Dijkstra is already kind of sketchy, and here it's just like, yeah, I can do 4174 for SuperPi. So yeah, solid little kit of BDI. There is a cheap, like, the thing is, they also make this as BDI in a 4000 megahertz bin. So that's the other option you can look for, is if you don't want the 4400, they do have a 4000 1919, and I think that's a 1.4 volts rated kit. And that's probably going to be, like, I'm not sure how it works out on average, if they're, like, similar quality or worse quality. Well, they should be worse quality, but the thing is I've heard, like, the thing is the binning that they do for, like, XMP settings is not exactly particularly indicative of the really, like, of what you can do at extremely high voltages. Because there's some kits which do really, really well at low voltage, and then you raise the voltage way up, and they just don't go anywhere. Yeah, so whereas this starts out at already relatively high voltage, and then it just keeps getting better and better and better. So, yeah, that's it. Now it's finally it for the video. I've run out of things to say. So, yeah. Cool kit of RAM. Don't think you can actually do what I just did with one of these. But yeah, solid memory. I'm kind of considering picking up a second kit, but there's a really good chance that one might just completely suck. So, and also thank you to the Patreons for the patrons for well, basically funding the purchase of this memory kit, because obviously, like, I actually went and bought it. So, because it was on sale and rather cheap. And even now, like, you can actually, like, these kits, even when they weren't on sale, these were going for like 130, and now they're going for like 100 to 110 depending on which store you find them at. So yeah, really cheap BDI. And the stock settings aren't even that bad. And I keep pointing to the wrong thing because the camera is, like, flipped over and whatever. Anyway, so yeah, that's it. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon where you can support me directly. There's a link to that down in the description below. And then if you don't like Patreon, there's also the AHOC Teespring store where there's, like, stickers, posters, shirts, that kind of thing. You can support me by buying those things as well. And there's a link to that in the description as well, of course. So yeah, that's it for the video. Thanks for watching, and goodbye.